Hey geometry honors, sorry to give you a video. Actually, you're thrilled that I'm not in class and you know it. We're gonna look at isosceles triangles in this video. Make sure you have this sort of guided notes from the sub, and then there's gonna be homework at the end. So fill out these notes as I go through it, and here we go. Make sure you have your theorem sheet, and we're gonna fill out the definition of isosceles. You've already learned what isosceles means, but I don't know if we filled this out yet. So definition of isosceles from our theorem sheet, a triangle is isosceles if and only if it has at least two congruent sides. That should be filled out if it hasn't already. We're gonna fill out a couple more in a minute. First, let's really talk about the components of an isosceles triangle. The two congruent sides, we're gonna call those legs, and the non-congruent side is known as the base. The angles down here that touch the base are known as base angles. And then the angle where the two legs meet, that is known as the vertex angle. All right, now, I want to look at this proof. Okay, now this is going to be a slightly different type of proof. If two sides match, and that's the only given we have, can we prove that two angles match? That's the goal of this proof. Now, first thing I want to do is I'm going to actually draw, for step one, I'm going to draw a perpendicular line from A to CB. I'm actually going to just draw that in, and you are allowed to do that in a proof. I'm not going to make you do this on any proofs in the future, so for the reason, we're just going to write shut up because I don't really care what the reason is. I'm never going to make you do that. But I just wanted to emphasize that we started with just a basic isosceles triangle. So we drew a perpendicular line. Now, can we prove these triangles congruent? Because that's really the point. If I can prove these triangles congruent, this one and this one, then by CP/CTC, these angles would match. Okay, so you can certainly hit pause on your video if you want to try to figure it out yourself, but my plan is I've got the perpendicularity, I've got a reflex, I've got the given. I think we can prove these congruent. Oh wait, that's ASS. No, it's not. We can use HL. So here's a good practice for HL. So first things first, I'm going to call this point D down here, and I'm going to state that these are both right angles. Angle ADC and angle ADB are right angles, and the reason is definition of perpendicularity. Now, I don't have to state them congruent like I usually do for HL. HL, and that's my plan, means I have to now state they're right triangles. So triangle ADC and triangle ABD are right triangles. So just make sure you see the difference in these two statements here. I'm just stating the angles are right, I'm stating the triangles are right. That's definition of right triangles. I can do the reflex. Sorry, this is not aligned very well. I can state the given. It took me till step 5 to really get to that given. So AC matches AB. Now the triangles are congruent by HL, and then by CP/CTC, angle C matches angle B. So I just want to reiterate what just happened here. We started out with just a basic isosceles triangle, and we proved that if two sides match, then the two angles opposite them have to also match. Okay? In other words, if the two legs match, then the two base angles have to match in an isosceles triangle. This is known as the isosceles triangle theorem. We just proved it, and we're going to fill it out on our theorem sheet. All right, so here it is, isosceles triangle theorem. If a triangle has two congruent sides, then it has two congruent angles. And the angles have to be opposite the sides. Now, there is a converse to this theorem. I'm going to do the proof super fast. You don't have to write this down, and if you really don't care, you can fast forward. But the converse, we'll call it CON for converse. Isn't that clever? The converse is saying, what if I know two angles match? Could I prove these two sides match? That's really what the converse is saying. Well, I can still draw this by reason of shut up. I can make it perpendicular. Would you agree that these two triangles have to match? We have the given. We have the definition of perpendicularity. We have the reflex. I would have to state these angles congruent because this is an AAS proof. Okay, so triangle COV is going to have to be congruent to triangle NOV, looks like by AAS postulate, and then by CPCTC, those two would match. Okay, so that's a wussy proof for that. So if you go back to your theorem sheet, the converse of isosceles triangle theorem, if a triangle has two congruent angles, then it has two congruent sides. Make sure you know the difference between the basic, which says if sides, then angles, and the converse, if angles, then sides. I need you to see that difference. Sometimes you're going to use one or the other. All right, so now let's use it. Let's use these theorems. So we're going to do a few practice problems. Please fill these out as we go. Again, you can always hit pause if you want to try to do it by yourself. Now, this here, I see that this triangle is isosceles, so the angles opposite the sides must match. So I know these two have to match. Now, if all the triangle adds up to 180 and we've used up 40, I'm left with 140 degrees to split evenly amongst these two. So I think each of these is 70. We have a linear pair here of 110. And now this triangle is isosceles. Because these two sides match, that means the angles opposite them also have to match. So if that's x, and we can do what we did before. 110 plus x is 180. We can write that as an equation, or we can just do it how we did last time. So it looks like 2x is 70, and it looks like x ultimately is 35. An isosceles triangle has base angles that are twice the measure of the vertex angle. Find each angle measure. So what's happening in this isosceles triangle is the base angles, which I'll call B, and the vertex angle I'll call V, we know they have to add to 180. So this looks like we could turn it into a system of equations. So there's equation 1, 2 base angles plus vertex is 180. The other equation is what it says here. Base angle is twice vertex. That's what it says right there. So now I can use substitution. I can replace the B with 2V. So 2 times B, which I'm calling 2V, plus V is 180. That means 4V plus V is 180. Let's solve this, simplify it. That looks like V is 36. The vertex angle is 36 degrees. The base angle will be double that. The base angle is 72. So we have a 36, 72, 72 in terms of the angles. All right, let's look at the next one. Consider triangle Cry with the following coordinates. Which angles, if any, are congruent? How are we supposed to get angles out of this? Well, one thing we could do is we could determine, using the distance formula, if this is equilateral, isosceles, or scalene. Because if sides match, then angles match. And this goes for equilateral. If I have an equilateral triangle, that's just a special case of an isosceles. If all 3 sides match, that means all opposite angles have to match. So let's come back to this. Let's do the distance formula for CR, for RY, and for CY. And then we'll see how the sides compare. Now, remember the distance formula. I'm going to apply it very quickly because you guys were always good at this. But that's the distance formula in case you forgot. Now, I'm going to apply it. So CR is -1 minus 6 squared plus -3 plus 2 squared. Again, you should be able to do this on your own. So that's the square root of 50. Now, I could simplify that, but I don't need to waste time. Who cares? Let's leave it at the square root of 50. We're just comparing sides. I'm not asking for a final answer of what these sides are. So RY, we have 1 plus 1 squared plus 3 plus 3 squared. That looks like it's 4 plus 36. That's the square root of 40, so it's definitely not equilateral. Let's see what CY is. 1 minus 6 squared, 3 plus 2 squared. So we have 25 plus 25. Ooh, we have the square root of 50 again. So if I were to draw this triangle, it looks like CR is root 50, and CY is root 50. So if those two sides match, that means the angles opposite them have to match. So we have angle R is clearly congruent to angle Y. And that is our final conclusion. All right, almost done. I would like to walk you through one proof using these theorems, just so you can feel comfortable with that. So we're going to do this proof. Now, it's good to have a plan before you just jump in and start writing things down. I need to somehow prove that AZ matches JW. So it might be nice to try to prove these triangles congruent, these shaded ones. Well, we definitely have that. We have AK matches JK, so we already have 2 items. I just need one more. It says given angle KZW is congruent to angle KWZ. Well, shoot, those angles are not in the shaded triangles. But wait, if these 2 angles match, doesn't that mean this is an isosceles triangle and therefore the sides opposite them must match? Could that be our third item? Well, let's just double check. I'm going to list this given first because I'm going to use it directly. AK congruent to JK. That's given, and again, that's right in the triangles we're trying to prove congruent. That's nice. I'm going to state the verticals now because that's right in the triangles we're trying to prove. AKZ and JKW, and those are verticals. Now, the other given, these angles down here, which are not in the shaded triangles, we're going to use those, as I said, to show sides congruent. So we have what's called the converse of the isosceles triangle theorem, which says if 2 angles match in a triangle, then the sides opposite them match. So KW has to match KZ. And that's by the converse of the isosceles triangle theorem, because we went from angles to sides. If it went from sides to angles, we would just use isosceles triangle theorem. So now we have our third congruency. Now we're ready to state that the triangles AKZ and JKW are congruent. It looks like that was an SAS. Side, angle, side, and then we can use CPCTC. So look out when you're doing proofs that this is now fair game. Okay, your homework is the next set. You've got some angles and a couple of proofs. Good luck.